I'm Anil Kumar, and I hope you enjoyed the journey with me of solving this very interesting problem on flight of Osprey. This question was taken from page 243, Nelson Advanced Functions, Unit 4. It's a very important question, as you all know. Normally it comes in assignment or sometimes a test problem. The problem given to us was: the following table shows bird's height above the water as given by an observer times 024678. Height was 7105003. We had to plot the graph, determine polynomial equation to model the data. How long was the Osprey underwater? When was the Osprey above 6 meter height? Estimate the rate at which Osprey's height is changing at the time it hits the water. So what we did initially was that we didn't really plot the graph, but we found the equation first, right? So we did part 2 of this, that is determine the polynomial equation to model the data. And here is the portion which you can see and relate to. So this is how we did it. We took these two x-intercepts, x minus 6 and x minus 7, and we just assume the third intercept to be at b. So x minus b will be a factor times a. These two unknowns, a and b, were calculated using the other 2 points, 0, 7, the y-intercept, and b as 4 and 5. So those are the calculations, and we got the equation h of t equals to 1 over 6 times x plus 1 times x plus 6 times x minus 7. So basically this is minus 1. Okay, so that is how we found the equation to begin with, right? And then we explored further and we did how long was the Osprey underwater. This was fairly clear. The Osprey was underwater between time 6 and 7, and then we found when was the Osprey above 6 meter height. So in the next video, which you can see in details, we answered these two questions. 6 to 7 is when the Osprey is underwater, and more than 6 meters, we substituted many values and figured out that it is from t equals to 0 to 3.6 seconds approximately. 3.6 seconds gave us a value of 37.53, which is more than 36. 3.7 gave a value of 35.67. And then we did this part and the next in the video which I just showed you. And then we had to estimate rate at which the Osprey's height is changing. Now that part, here is the solution. The next video had that part, that is, we applied our formula, the model, h of t equals to 1 over 6 times x plus 1 times x minus 6 times x minus 7. It hits water at t equals to 6, so we did rate of change, preceding rate of change. H of 6 minus h of 5.99 divided by 6 minus 5.99, calculated the value, which was negative minus 1.1766. It is expected, and you can see the tangent is going downwards. That is negative, right? Since the Osprey is diving in, right? And now we are almost at the end, and we will now show you the graph. The last part is the same question but graphically, right? So we'll try to find rate of change graphically, and this is the current topic of the video. So here is the graph for you. So we have the same question, the same data, right? 0, 2, 4, 6, 7, 8. So at 0 we have a 0.7, correct? At 2 we have a 0.10, you can see that. At 4 we have 5, this is 5 for us. At 6 the point is 0, and at 7 again it is 0. You can connect all these points and get your graph. The model for us is h of t equals to 1 over 6 x plus 1 x minus 6 x minus 7. We found the value of a and this intercept using these 2 points, correct? So I've just extended the graph to show you that this is at minus 1. So that's a perfect cubic polynomial before you, right? Now in this graph we are going to find rate of change when the Osprey just dives in or hits the water level. So I've drawn a tangent line. You can see very clearly the tangent which passes through, just touching at t equals to 6, and we can find rate of change from rise over run, correct? So if you see here, that is the rise, which is basically a fall by 7, right? So we can say, let me use another ink. So we say rate of change at t equals to 6 is, so from this graph, 7 minus 7, is it okay? And the x value change is 6, right? So what we did here is delta y over delta x, that is rate of change, right? So we can calculate this using the calculator. The answer is, we'll do 7 divided by 6, which is equals to 1.166. So it is negative 1.166, right? So which is approximately 1.17, and that is what we got when we did algebraically also, right? So I think with this we have shown you the complete solution of this interesting question, which was picked from the book Nelson, page 243, unit 4. You can go through all these videos. There are, I think, 4 in all. In the first we discussed the question, then one by one we solved each part, and at the end we have compiled them all in this video. I hope that helps. You can subscribe to my videos and learn a lot. Thank you, and do share your comments and remarks. All the best for your test.